Let's now get some practice with separable differential equations. So let's say I have the differential equation. The derivative of y with respect to x is equal to 2y squared. And let's say the graph of a particular solution to this passes through the point 1, comma, negative 1. So my question to you is, what is y when x is equal to 3? And I encourage you to pause the video and try to work through it on your own. So I'm assuming you've had a go at it. And the key with the separable differential equation, and that's a big clue that even calling it the separable differential equation, is that you separate the x's from the y's, or all the x's and the dx's from the y's and dy's. So how do you do that here? Let me just rewrite it. So it's going to be dy dx is equal to 2y squared. We can multiply both sides by dx. And let's see. So then we're going to have, that cancels with that. If we treat it as just a value or as a variable, we're going to have dy is equal to 2y squared dx. Well, we're not quite done yet. We get this 2y squared on the left-hand side. So we can divide both sides by 2y squared. The left-hand side, we could rewrite this as 1/2 y to the negative 2 power dy is equal to dx. And now we can integrate both sides. What is this left-hand side going to be? Well, we increment the exponent and then divide by that value. So y to the negative 2, if you increment it to y to the negative 1 and then divide by negative 1, so this is going to be negative 1/2 y to the negative 1 power. And we could do a plus c like we did in the previous video, but we're going to have a plus c on both sides, and you could subtract different arbitrary constants on both sides, and you could subtract them from each other. So I'm just going to write the constant only on one side. So you have that is equal to, well, if I integrate just dx, that's just going to give me x. So this right over here is x, and of course I can have plus c over there. And if I want, I can solve for y. If I multiply both sides by negative 2, and then I'm going to have the left-hand side, you're just going to have y to the negative 1, or 1 over y, is equal to, if I multiply the right-hand side times negative 2, I'm going to have negative 2 times x plus c. And then if we want, we can take the reciprocal of both sides, and so we will get y is equal to 1 over negative 2x plus c. And now we can use the information they gave us right over here, the fact that our particular solution needs to go through this point to solve for c. So when x is 1, y is negative 1. So we get negative 1 is equal to 1 over c minus 2. We could multiply both sides times c minus 2. Then we will get 2 minus c is equal to 1. And then let's see, I can subtract 2 from both sides. So negative c is equal to negative 1. And then if I multiply both sides by negative 1, we get c is equal to 1. So our particular solution is y is equal to 1 over negative 2x plus 1. And we are almost done. We didn't just ask for the particular solution. We asked, what is y when x is equal to 3? So y is going to be equal to 1 over 3 times negative 2 is negative 6 plus 1 is going to be equal to 1 over negative 5, or negative 1/5. And we are done.